Hello everyone. So today we're going to share the story of a transformation. The transformation of a team and an application that started with a monolithical approach and had to evolve to adopt a modular and extensible approach. So my name is Stéphane Bégodeau. I'm software architect at OBO, working on Sirius Web. I've been contributing to various open source projects in the Eclipse Foundation for 14 years now.
And I'm Melanie Batz, a CTO at OBO, a fan of open source software and a contributor to open source projects within the Eclipse Foundation. OBO is a software company based in France. We're about 60 people spread almost all over the globe now. So, we're here to talk about architectural change, of course, but first, let's share a bit of about our context. The story we are going to tell you took place around an open source software project called Sirius Web. Sirius Web is a low-code platform that allows users to create web applications for graphical languages. The project was started almost 5 years ago, and we currently have around 13 active committers. We release a new version every 8 weeks, and the code base consists of roughly 500,000 lines of code.
Okay, so what actually is Sirius Web? Well, it depends on who you ask, because Sirius Web means different things to different user profiles.
So, Sirius Web is an application that allows you to work with your business domain using dedicated tools. With it, you can define a specific vocabulary through business concepts, specify how these concepts should and could graphically be represented, and determine how your users will interact with these concepts. So this way, the user of your application can create instances and work with a tool that is fully tailored to their vocabulary. So, Stéphane, can you just show us a more concrete example of what I just explained?
Yeah, sure. So, here we have the graphical tuning of Sirius Web, which allows us to define the concept that we want to work with using our custom-made tools. Once the concepts are defined, we can start describing representation that will enable us to work with this concept. Here we can see what the small example I've described just before allows us to achieve. In the Explorer on the left, I can navigate, create, and manipulate instances of my concept. I can view their properties in the detailed view on the right, and in the middle, there is a diagram, very simple in this case, to visually represent the relationships between my elements.
So, the next thing is that developers creating applications based on Sirius Web don't just want to work with what we provide by default. They need the ability to extend our platform, customize behaviors, provide their own concepts, and even introduce new types of representations. Stéphane, do you have some more concrete examples?
Yes. So here we are on a completely different domain. On the screen you can see Eclipse Season, a modeling tool for system engineers that is using Sirius Web as a platform to provide custom tooling for those engineers who will build trains, planes, satellites, and more.
And we go even further. Our framework must allow us also for, for components that can be partially reintegrated into the applications that consumers, much like kind of add-ons, but in a web application.
So, Sirius Web is also, like many open source tools, a community. And the fact that Sirius Web is reusable means that we have many stakeholders looking to see the product evolve in various directions. So, have you ever had to fight demons in your code?
Raise your hand if you have ever felt like your product is kind of wild beast, slipping out your control, ready to turn against you at any moment. Do you have this kind of issue? Or some of you, lucky guy if you don't have that.
Or if small changes that you wanted to make in your code has a ton of unforeseen consequences. Well, this is the beginning of this story.
Yeah. So, Our concept is this open source project, which is becoming quite substantial in terms of volume, both in lines of code and the number of people involved, with some pretty airy issues around consumption, extensibility, and modularity. So it's starting to feel like a real mess. So how do we get out of this situation now that we've reached this point? So I once read a book. I read a book with this law. Organizations that design systems are constrained to produce designs that are copies of their communication structures. Simple, isn't it? Okay. To put it simply, what we can take away from Conway's law is that we have a sort of mirror effect. The software and the organization of the teams just overlap.
So, at one point, we had no choice. We had to confront our demands both technically and organizationally.
Yeah.
So, one of the first technical challenges that we had to face was the FT monolith that we had. You never quite know where to start to understand an issue, nor where it'll lead you.
On the team side, one of the first demands we faced was the code phantom. You know that code you write but never integrate. You either spend your life rebasing it or let it quietly die in its own branch, but yet it still haunts you.
Binding. So no matter how well you organize the code, the devil hides hidden in the details. Responsibilities can be scattered everywhere, making it impossible to reuse anything without pulling the entire code base, an absolute nightmare. So without this demand, we are far from being able to reuse any part of Sirius Web without fighting this one.
I really like this one. It's a kind of specter that drags your team down. Its job is just to do everything it can be to hinder your progress, constantly placing various obstacles in your way to slow you down.
So with all the use cases that we need to cover, we have to move quickly. At that point, it's no surprise that this demand catch up to you. So how do we structure things and avoid getting lost in all of these changes?
This one is scary because it doesn't just affect your platform team, it especially thrives on the downstream projects that rely on you. So ultimately, it feasts on the time and energy of those trying to use your platform, but struggling or having to put in enormous efforts.
With Sirius Web, we need to adapt to the need of our community. And in that case, this is a challenge that will stand in our way and try to stop us.
My final team-related challenge, but certainly not the least, is that in our open source world, this challenge hinders external contributions, preventing feedback on your work and discussions about the needs of downstream projects that are using your platform.
And even if we succeed in creating a piece of software that meets all of our needs, we must also address the requirements from our community to enable them to go beyond what we envisioned for Sirius Web. Yet again, there's a demand in our way preventing us from opening up to the world.
Phew, that's quite a lot of work ahead. 9 demands in total?
Yeah, we need to perform a serious exorcism. 9 demands, a whole collection of hit points. It won't be easy.
No. My favorite part now. Time to take down those demons. But we need the right tools for that, so let's see what's in our toolkit. Our first weapon against the demons is the language blade. So it's a sharp tool that aligns everyone with a common language. Stefan, what does this look like when you applied this principle to our code?
So to add flexibility to our monolith, we applied best practices from microservices architectures, particularly domain-driven design. First, we needed to establish a common language. We faced confusion as different team members or different person in our community use different names for the same software components, complicating the navigation through the code or the documentation. So we started a review of all of our concepts to rationalize our vocabulary and initiate an harmonization effort. It's an ongoing task because as the software evolves, so must our language. So we've defined clear boundaries for the different business areas by implementing dedicated sub-languages for each software component. They are now formalized and synchronized with the code, ensuring the consistency for the end users. So here you can see a part of our language dedicated to diagram specification. Users can manipulate this language to configure the appearance and behavior of the nodes inside of a diagram. Here, for instance, we've defined that the label of the node will use the first name and the last name of a character. Ultimately, whether it's in the documentation, technical artifacts, code, or user interface, we've ensured that all project stakeholders are using the same vocabulary.
On the team side, we reorganized our structure. So we mapped relationships among our teams using concepts from a really good book, which is named Team Topologies. Read it if you're a team manager. We found many parallel projects communicating chaotically, leading to misunderstandings due to too many contacts with different languages. So to streamline communication, we introduced a single point of contact, which we named our enabler. They ensure everyone speaks the same vocabulary while integrating the downstream project's context, and it allows us to avoid repeating explanation again and again. So enablers bridge the platform and other teams, serving as the platform voice, and we can see enablers essentially like if they are translators.
Okay, so that tool worked. It weakened the binding demand and the resource vampire, but they're still there. So what else can we do to hurt them?
So I can present you the splitter hacks. It's a powerful tool for breaking monoliths and clearly defining contexts. So what results could we have using it?
So after reorganizing all the concepts of our language, we tackled our code structure by moving to a monorepo. We consolidated scattered code across multiple repositories and broke down large modules. This clarifies dependencies and distributed responsibility much more effectively. So here, for example, you can see the outcome of our technical restructuring, featuring a series of components, each with different level of dependencies.
So the monorepo approach has greatly simplified our integration challenges. Previously, few felt empowered to review or integrate others' code, often waiting for Stefan's approval. So he became overwhelmed, spending all his time on code reviews, and we were really close to losing the battle against the demons. So the monorepo clearly redefines these responsibilities, allowing us to share them effectively. And then we also implemented the GitHub's code owners who are using that to make these roles really transparent. But I think that your magical axe has also enabled even more restructuring, right?
Yes. So in addition to restructuring the code, we also modernized the architecture. So we previously had a classic layered architecture with controllers on the top, depending on services, which in turn relied on the persistent layer. It worked quite well until we tried reusing part of the code for other products. So you want to support for representations, that's fine, but the data structure are in the persistence layer, but they don't have any behavior. So if you want the behavior for the representation too, sure, just use the service layer, but it depends on the persistence layer. And then you're locked. You can't manage the lifecycle of the application as you want. If you want to reuse the front end, then you'll need the controller of the back end too. At this time, you can take the whole application or just fork it if you don't like how it is structured. So we changed that and also relied on best practices from the domain-driven design approach, completely rethinking our architecture and rewriting a significant amount of code. So previously, the entities were completely empty of behavior in the persistence layer. Now they contain the business behavior with dedicated services. So the domain layer contains core business rules and reusable services without any external dependencies. In some specific use cases, we still have some annotation for basic persistency, like at ID or things like that. We've also merged the controller and other part of the service layer together into a new application layer, keeping the integration services for external pieces of technologies, such as EMF, for example. Finally, the infrastructure layer isolates all the configuration for database, security, HTTP, WebSocket configuration. As a result, we add a very, very reusable domain layer with both data structure and behavior, and an application layer optimized for those who want to reuse Sirius Web as a platform. So this restructuring led to more than 3 dependency levels. We have at least 5 levels of granularity in our dependency in the backend now. So if we take the diagram, we have first the part which is fully reusable without any dependency whatsoever. Then the module to bring the support for the life cycle of the diagrams inside of our collaborative system. Then we have the GraphQL controller that can expose the dedicated diagram API without any network dependency. On top of that, we have the integration of the declarative language that you have seen in the screenshots at the beginning of the presentation. Without this, you can only configure them programmatically. And finally, the application layer, which connects all that to the HTTP, WebSocket API, the rationale database persistency, and so on. In the end, with this technical restructuring, it allows us to create a project for the CEA that provides scientists with a tool integrating Sirius Web inside of a VS Code extension. This extension can be used entirely offline. It embeds the front-end and back-end code, but it reuses about 20% of the code of Sirius Web without any connection to a remote server.
Right, Stefan, the monorepos, the hexagonal architecture, and the code owners have hit our demons hard, and I'm pleased to announce that we've beaten the overgrown beast and the code fountain, so let's keep going.
So alongside this technical separation, we also focused on a functional separation of our code based on our language main components. So with this dual approach, it allows us to enhance our code reusability and clarify even more the responsibilities in the code. So to ensure that this separation is kept over time, we've also implemented architectural tests to prevent regression in technical or functional dependencies. So in the end, we have code blocking some part of our code from depending on other parts of our code.
So the bounding context principle is solid, but our developers need to learn also to segment their contributions. So at that time, reviews used to be chaotic, with everything arriving, just before the release date, so which was almost unsustainable. To tackle this, we introduced the concept of scope. So when starting a task, you only have a vague idea of what needs to be done. It's like this potato. As the developers take over, these shaping outlines start to reveal specific tasks and actions, the little dots. And day by day, as the iteration progresses, we refine the scopes of what needs to be done and integrate them. That's really important, we integrate them. So instead of a big, heavy potato coming in, we now have a kind of salted potatoes, much easier to eat, and especially if you had some more grease. So we break tasks into manageable pieces for better integration. And if done right, we deliver functional features, and this boosts team efficiency. So to add some more fat in our potatoes, we introduced 2 touch points to enhance team communication. We have a 15-minute daily stand-up for status updates. And we have also a 1-hour weekly meeting to review scopes, and so adjust as needed according to the iteration and where we are.
The balance is shifting. Those demons won't be so bold now.
Yeah. So that's a great news. That's one less demon, but we're not done with your magic hacks yet. I think that it could have some more superpowers.
Yes, so we've split our monolith into modules with clear responsibilities. But instead of bringing back direct dependencies between those modules, we've decided to switch to an event-driven approach to make those modules communicate. It makes the application much more flexible and scalable. Event-driven architecture can be intimidating, but we're still working inside of a monolith. It's just a modular one. It gives us the benefit of modularity and extensibility without the complexity of a microservice architecture. Microservices can be great, but they're not required for modularity, and not everyone is Netflix. In our case, we have no latency issues, no data loss, no serialization overhead. Tools like Kafka are great, but they are completely overkill for our needs. On top of that, monoliths are way simpler to code, test, debug, maintain, and deploy. And for our customers, deploying Sirius Web applications is a breeze.
So as we broke down our code, we managed to integrate more components and wanting to make this modularity available also to downstream projects. So we started by documenting all changes in a changelog, updated with every PR. So what I mean is there is no pull request which is accepted without a changelog entry. This is quite strict, but really effective. However, writing what we did isn't always clear for everyone, so our enabler steps in again. His role is to help downstream projects to adopt new features, and he's here also to guide teams on using the new components through different kind of communication, written exchanges, meetings, or even pair programming.
We're making progress, but there are still some challenges to overcome.
Okay, so we have another tool, which is called the Sync Orb. It's like magic. It keeps all our code and teams perfectly aligned and can even predict problems before they happen. So would a kind of synchronization tool like this could be helpful for you?
Sure. So how are we using this event-driven approach in practice? So here are some numbers to give you a generality. We have about 60 internal events for the synchronization within the backend. We're close to 200 for events sent by the front end to synchronize the backend, and the other way around, we are at 70 events that can be sent by the backend to synchronize the part of the front end. Okay,
so you need synchronization in the software. From team side, we've also synchronized our development cycles too, based on these 8-week iterations. So to quickly meet customer needs, we have frequent API changes. So we are not using calendar versioning. Instead, we are using semantic versioning. No, this is in the reverse way. We are not using semantic versioning, but we are using calendar versioning in order to allow downstream projects to track feature gaps. So we are not using also snapshot because we think that upgrades are a kind of collective decision. We have 2 6-week parallel cycles, one for the discovery, which is led by the product owner, and the second one for the delivery, led by the developers. We have 2-week cooldowns between our 6-week cycles to plan the next iteration. So we are releasing a platform. So releasing the platform is just one step, just one of the products we have to maintain. So we have also aligned all downstream products we have at OBO. We are here to manage at around maybe 5 to 10 products. So all these products need to consume new version, and this as quickly as possible, avoiding full cycle waits. So what we did is we don't have just one 8-week cycle, but we have our 8-week cycles which involve multiple products. We have sync points every 4 weeks where a decision-making team, including executive, sales, marketing, and products, will align on the status, the objectives, and the priorities for all the products at the same time. We'll use shapes to outline potential topics early on, allowing us to define features, align expectations, and so prepare the tech team also. This really helps clarifying scope and communicating upcoming changes also to our community, to our downstream project. So based on these shapes, we will write an architecture decision record. This is from the team side, the technical team. So this idea is here to identify technical changes. This collaborative process helps anticipate issues and communicate potential API breaks to our community before starting to code. So this is really important. Our enabler also will bridge the gap between the teams again. It will coordinate the intermediate releases, and it will reduce also integration friction by enabling really early consumption of incremental versions.
We're close to victory.
Yeah.
Most demons have been overcome. So now we can clearly separate responsibilities in our code, in the team, synchronize various parts of the code, the project, and our community.
But we still have some challenges to overcome, I think. I could propose our extension one. This could be the solution. It's a powerful tool that easily adds features and adapts to future needs.
Great. So in Sirius Web, we are relying on GraphQL extensibility for our backend architecture. Extensions to Sirius Web can seamlessly introduce new types, new attributes into the GraphQL schema. In the front end, we can also dynamically add new React components, which can come with new queries, or we can even change the behavior of existing one to accommodate evolving requirements. So every big part of Sirius Web is coming with its own contribution to the GraphQL schema. We have close to 20 parts of the GraphQL schema in the backend of Sirius Web today.
Our enabler is again here. As I said, it is a very pivotal figure. It bridges the gap between the components also. So it facilitates both top-down information flow and also bottom-up contribution from downstream projects. And that's really great for an open source project. So by guiding and monitoring these projects, the enablers identifies and facilitates necessary upstream changes. So thanks to the enabler, the downstream project can provide shapes, ADRs, and PR. So the enabler will review that. He will ultimately be the one that will review that because he has all the context from the downstream project and from the platform project. And this ensures that contributions are seamlessly upstreamed into the platform, and that's really important.
I think we've reached the final line.
Yeah, that's right. We have completely wiped out the finite 3D months. So it's the end of our quest. So what should we remember from this?
Well, in the end, transforming our monolithic application into a modular and extensible system required us to deploy various solutions to overcome a large set of challenges.
Yeah. So I think we can all agree that this is a clear-cut victory. Yeah?
Yeah, but it's not quite a complete victory. We still have a few challenges to overcome and a tool we haven't fully utilized yet. The scalability hammer. So while we'll achieve parity in software performance, we've seen great improvement in team scalability. We still have some work to do on the software performance side.
Yeah. Okay, so with these tools in hand, you can now cleanse your code base and your teams of the technical debt and inefficiencies that have been holding you back. So now it's your turn to embrace flexibility and modularity. And yeah, if you have any question,
yeah,
we'll be happy to answer that.
To answer any question.
We want to thank you for your attention. And if you want also to learn more about Sirius Web, modularity, Monolith, breaking your monolith, you can visit us at our booth. So it would be great to discuss with you. Do you have some questions? We have some time for that.
I do. Hello.
Yeah.
So I wanted to ask about the versioning because, well, you do use GraphQL. So in theory, I would guess you would not need to version your GraphQL API. At least that's one of the theoretical selling points of the architecture. So how does versioning play into it, and what do you see that you need to change that's breaking in order for you to version your APIs?
Okay, so as we said, right now our priority is to be able to deliver fast improvements to our community. So we are both on the front end, back end, or the GraphQL API, we are adopting a calendar versioning, and we are not, for example, performing maintenance releases with a deprecation of our APIs, things like that. But we could do both on the Java or TypeScript or GraphQL API. So there's nothing specific for GraphQL in our strategy. We have just clean break in the API when it's required. But that's why we have the calendar versioning to measure the distance between members of our community and our latest release, and to check how far are they from the latest features. Because right now, since we need to move quite fast to deliver new features, we know that we can slow down to perform maintenance release that pretty much no one in the community is asking for now, or we could use semantic versioning, but every release would be a major release. So we are not using anything specific in the GraphQL part, but we know we could do it.
Other question? Yeah, another one here.
Okay, thanks you. It was a really nice talk.
Thanks.
Yeah. So code rottens. And if you don't maintain it, it rottens. And once good code becomes garbage.
Yeah.
So that's more or less a topic before you deliver features, but how you do with continuous refactoring. So clean up the code after some changes so that it is also nice code in 10, 20 years.
Okay, so we are doing exact, in fact, in our cycle. When I said that we are choosing the topics, refactoring is one of the topics we could choose as an executive team, as a decision team.
Yeah.
So we decide to switch from our old architecture to the new one. So this is a kind of refactoring. So we decide that. Also, there is this small cooldown things. So during the cooldown, the team can choose also to work on refactoring what they think is important for them. So we keep some time in the cycles for the team to do what they think it's important to do, to be sure that the code will be maintained on the long time. We also have lots of things in our CI also to check that the code is okay. We have some coverage things. We have architecture tests. You can maybe go further on that.
Yeah, there's two main parts in the code of Sirius Web. There's the Sirius components part, which is highly reusable and well organized, and it's well maintained, because every time someone asks a new feature for diagrams or things like that, this code needs to be updated. It is updated very frequently. And we have this other part which is in the Sirius Web modules that was getting a bit old, I would say, compared to some of the latest best practices that we had in the Sirius components part. So I think it's 1 year ago when we had some major consumers of Sirius Web in our community, like Papyrus Web, for example, which needed a lot of new features on those parts. They had no other solution to move fast than forking the code. But we kind of made a deal with them saying, okay, you fork this code, but we'll start restructuring it to make it modular and extensible, and then we will bring you back, we will help you get back on the new version. And I think it's 2 months ago or something like that, we completely eliminated all those major forks in the downstream projects of our community. I think we had 3 forks at least. So it's quite a success to have been able to modernize all this part of the code and to stop the people that fork the code, because it's very complex to bring back people on the main branch after they started to leave because the code is not as updated as they wish.
Okay.
Thanks.
I think we're over time, so thank you all. This is blinking. Stop, stop, stop. So thank you all, and if you have any question, visit our booth.
Thank you.
Thanks.